The last way that we can learn how to solve systems of linear equations is called to solve by elimination or the addition method. So I'm just going to show you by example how this is going to work. So what you're going to do is take the two equations that are written next to each other and write them on top of each other. So choose one to go on top and the other one to go on the bottom. Okay, and then you're going to take a look at the variables themselves and see if any of them match. If any of them match, like for example 1x and 1x, we can actually eliminate that variable by adding or subtracting the equations together. So in this case, the only way that we can eliminate x is if we are to subtract this entire equation from the first one. So in other words, x minus x cancels out. Negative 2y minus 1y is negative 3y, and 2 minus 5 is negative 3. So now we have a nice equation that only has one variable in it, so you can just say that y is equal to 1. Well, now that we know that y is equal to 1, you can take y equals 1 and plug it into one of the equations. So I'll choose the second one. So then we get x is equal to 4. So our answer is 4 comma 1. So the goal here is to eliminate one of the variables by using addition and subtraction. Okay, again, you want to make sure you're writing the equations one on top of the other. But unfortunately, for number 3, we don't have the variables lined up properly. See how this equation, the y is alone? We don't want the y alone. We want the exact equations lined up so that the x's are aligned and the y's are aligned. So that means that we have to subtract that 2x to the other side. Okay, now you'll notice that the second equation doesn't have any variable that's exactly the same, but there is a way that we can change it or manipulate it so that we are going to have one of the variables the same. Well, isn't it true that we can change a negative 2 to look like a 4 by multiplying the entire equation by positive 2? So we're basically distributing 2 to every single piece of the bottom equation and then subtracting. 4x plus 2 times negative 2x. Well, 2 times negative 2 is negative 4. 4x minus 4x cancels out. Negative 2y plus 2 times y cancels out also, so we get 0. 6 times 2 times negative 3 would be 6 plus negative 6, which is 0 again. So this is our true statement. And a true statement implies that we have infinitely. There are infinitely many solutions. Okay, we're going to move that 2x to the left-hand side so that we're lined up. And we have x plus y, 0. If you notice, the y and the y are exactly the same, so what we're going to do is subtract these two equations. Negative 2x minus 1x is negative 3x. Y minus y cancels. Negative 6 minus 0 is negative 6. Therefore, x is positive 2. Now that we know as x is positive 2, we can plug it into one of the equations. And we get y is negative 2. So your solution is 2 comma negative 2. And last one. The x's and y's are already lined up. 2x plus 3y is 1. 3x plus 4y is negative 2. So we'll notice in this equation that neither one of the x's or y's can easily change into the other. So unfortunately, we're going to have to multiply both of these equations. So the top equation, if you want to change the x's, can be multiplied by 3, and the bottom equation can be multiplied by 2. So we're going to actually rewrite both of these when it's fully distributed. 3 times 2x is 6x, 3 times 3y is 9y, and 3 times 1 is 3. Similarly, 2 times 3x is 6x, 2 times 4y is 8y, and 2 times negative 2 is negative 4. Now, we can clearly see that the 6x's are going to cancel if we subtract. 6x minus 6x cancels. 9y minus 8y is just 1y. And 3 minus negative 4 is positive 7. Therefore, y is equal to 7. So let's figure out what the x is by multiplying 3 times 7 in the first equation to get 21. So 2x is negative 20, then x must be negative 10. So our solution is negative 10, comma, 7.